Hi there, welcome to this Python video tutorial on the subject of loops. So to follow this video tutorial, ideally you should have seen the previous video tutorial on functions and also the previous video tutorial on tuples and lists. Lists are going to be quite important. And so before we get started with loops, I want to just introduce another concept. In the previous video tutorials we've played a lot with these functions, so this function should be pretty familiar if you've watched the previous tutorials, circle area from diameter. And we've built lots of functions and we've called functions from within other functions. I want to address a slight issue here which I'm not 100% happy with, which is this, which is the precision of my value of pi. I've just typed in 3.142. As you all know, pi is an irrational number. It has a infinite number of digits after the decimal point, and I've only given it to 3 digits accuracy. So I want to introduce a concept, another important concept in Python called the import. So as well as functions you can create, Python as standard comes with lots and lots of built-in functions and variables that you can access. I want to show you an example. So there's a module. A module is a collection of functions and variables. There's a standard module in Python called math. And if I import math, I can actually type import, then I can access all the functions and variables that are within there. And if I type math, and then I put dot, you'll notice that I get this drop-down list of all these different functions in alphabetical order. So I've got arc cos, arc hyperbolic cosine, arc sine, so sine cos, I think e, error function, exponential, factorial, floor, lots of different functions. Some of these are functions and some of them are variables. So e, for example, is a variable equal to Euler's number. The one I'm interested in is this one, pi, which is a variable equal to pi. And if I just print that, press run, you'll see it prints out pi to many more decimal places than I have it specified here. And in fact, I think the value that it prints here, I think it's actually curtailed how many decimal places the precision is actually stored to. In fact, I wonder why can't I see it in the variable explorer? Oh, it's because I haven't assigned it to a variable. I'm just going to say a equals math.pi just for now. So there we go. Let's open that in a variable explorer. Okay, well yeah, you see that there it's displayed it again, but this is actually to 3 digits more precision. I'm not sure to exactly what precision it's stored within the computer. Well, I do know actually it's stored as much pi you can get in a 64-bit floating point number. And I'm not sure how many digits that is off the top of my head, but that's probably quite a few. What I want to do is, instead of having 3.142 here, I'm just going to put math.pi. So I call that pre-existing program variable instead of 3.142. And now if I call circle area from diameter, just give it some value. We'll do this just to check this works. Yeah, and indeed we've got some kind of answer at the other end. Okay, so that deals with that. So now I want to get on to talking about loops. So I mentioned earlier on, back in the tutorial about functions, I mentioned the idea that a particular reason a function was nice is you might want to execute that code more than once, and a function is a nice way of sort of containing that piece of code, and you can call the function multiple times and therefore you don't have to write out this piece of code multiple times. It will just get executed each time the function is called. And it's very common, it's a very common thing in computer programs to want to do something over and over and over. So for example, we might have a long list of circle diameters, and we might want to calculate the area for each of those diameters in the long list. And to do so, let's do that. Let's build a function that does that. So let's say define a function which is a circle. Let's call it circle areas from diameters list. Okay, and we'll give it an input which is a list of diameters. I'll call that dlist. And it's going to need a documentation string, which I guess will be quite a lot like this documentation string. Takes a list of floats, dlist, defining the diameters of circles, and returns a list of corresponding circle areas. Okay, so that's what we're going to try and do. And so to do this, we're going to use something called a for loop. So just before we actually get into doing this for real, a for loop is basically a way of executing a piece of code over and over and over a number of times. So the syntax for it is like this. We use a special keyword called for. It highlights blue when I type it to indicate that it's a special keyword. And let's say I want to do something if I want to do something 10 times in a row, I would say for I in range 0 to 10. Okay, then I'll press a colon. So range 0 to 10 just generates a list of numbers starting at 0 and actually ending at 9. So it will generate 10 numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it will do that 10 times in a row, and then if I hit return, you'll see exactly the same. You see this should be starting to become familiar now. We get this same behavior that we get when we define functions or when we had if and else statements. We get this indent, and any code that we write here indented under for will get executed 10 times in a row. Okay? And the I here is quite important as well. So each time the code under here gets executed, I is a variable, but it takes on a different value. It's kind of like this temporary variable, which changes value at each time we go through this loop. So on the first iteration of the loop, I will take on the value 0. And on the second iteration of the loop, it'll take on the value 1, then 2, then 3, then 4, and so on. And so a way we can see this is if we just print I. If I save and press run, nothing will happen, of course, because I've created my function, but I haven't actually called it. So if I call it that, I'm going to need to create something called dlist to pass into it, because I'm just going to create something temporarily like that. And run. And also what I'm going to do is I'm going to have to create let's do this. Okay, I'm just testing now. We haven't actually got anywhere near building the function we want. But if I press run and we look in the variable explorer, it hasn't done anything, of course, because it's not returning anything. What it's done is at each iteration of the loop, it's printed I. Okay, that's all I've asked it to do. And if we look here, I'll run it again. It's printed 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And if we show this by stepping through each line, if I step in here, so we see 4i in range. Okay, so if I press step once, we'll drop in to the for loop. If I look at my variable explorer, I see I've got a variable called I, which has value 0, and I've got a command which says print I. And if I press step, you'll see here that at the console it's printed out 0. And then if I step again, I go back into the loop, and you'll now see that I has the value 1, and it prints it out. And if you just keep your eye on this value of I up here, your eye on the value of I, and I just keep stepping, you'll see as we just keep stepping each time, the value of I increments by 1, and we just print it out each time, up until it gets to 9, and that's the last one, and then the list stops. Okay? So that's a very simple way if you want to do something 10 times in a row. It's actually not very common that you want to do something n number of times in a row. Much more common is that you'll want to, for example, do something to every element of a list. And in fact, that's what we want to do here. We want a list, and we want which contains circle diameters, and we want to calculate the area for each diameter in the list. So let's do that. So down here, I've defined this thing called, in fact, let's give this a different name. I'll say my diameters equals, and I'll create a list, and I'll just put some values in it. So 5, 10, 15, 20, that'll do. So we just put four values in the list. We'll pass that list to this function we're creating. Okay. I'm going to just change that to my areas. Okay. Right. Now, what we want to do in the function. So now, what's going to happen? Let's just step and just just try and keep an eye on what's going on here. So if I run, okay, run, step, 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 step in. So now I want to step into my function. I've passed it my diameters, which has gone into the function as dlist, because that's what the function expects. So if I look inside the function, I've got this list called dlist, which contains the values 5, 10, 15, 20, all integers. Okay. And it also gives me the index of these values. You'll recall from the tutorial on tuples and lists how elements in a list are indexed. Okay. So what I want to do is, in my for loop, instead of just going through some arbitrary number of times like 10, I just want to do something to each value in the list, namely calculate the area of that value in the list. So you can do that like this. So if I change this to D, so it doesn't matter what name I give this variable, this is just a variable I'm creating which is sort of temporary and gets assigned to a different value at each point in the loop. If I just do for D in D list, okay, what this is going to do, this is kind of handy, this is going to, regardless of how long the list is, so it doesn't matter now, I can pass it a list that's got 4 elements in, 10 elements in, 100 elements in, and what this function will do is it will go through each element in the list in the for loop. So if we step through this, let's do this. Let's stop. Let's go again. Step in. So first time I go into this for loop, the value of D here gets assigned to 5, which is the first element in our list. Okay, so D becomes 5. Whatever happens in the loop happens. At this time we're only printing it, we're not doing much more than that. And then it goes around again, and now D equals 10, which is the second value in our list. And again, D equals 15, d equals 20, and now we've reached the end of the list, and so it finishes. Okay, but we don't want to just print out the diameter, of course, we want to calculate the area, so let's do that. So we'll say area equals circle area from diameter d. Okay, save that and step through again, see what it looks like now. So this time, step in, check the variable explorer. We're in the list, we've got d equals 5. I'll press step once, and then the area is not appearing. In my variable explorer. For why, I do not know. Let's just try this. I think this might be a spider issue rather than an error in the code. Let's try again. Step this. Okay, we'll step in. Okay, so this time I'm asking it. Oh, for some reason now it's working. I don't know what I did wrong there. But here we go. So we've gone round. So we're in the list, the first loop of the list. The diameter equals 5, and it's calculated area. We've got this. We've created a variable within the list called area, which gets assigned the circle diameter. Now, within the loop. Anything we do within the loop, and particularly variables we create, you've got to keep an eye on those, because what's going to happen is those are going to keep getting overwritten at every step of the loop. So if I continue, we'll now go back through the loop, d will get overwritten, d is now 10, but as soon as we do this area calculation, if you keep an eye on this up here, the area gets overwritten now to the area of a circle with diameter 10. And if we go again, d is 15, and the area gets overwritten. So this is good, right? We're calculating the area at each step of the loop, but it's not really helping us very much because that area is getting overwritten each time we go through the loop again. So what we need to do is we need to have some way of permanently storing the area each step of the loop. And the way to do that is obviously, or maybe not obviously, but the way to do it is to add it to another list. So if I create a list called areas up here, and I'll just define an empty list. Okay, so that means a list with nothing in it. And then at each step, I'm going to do areas.append area. Okay, so this will add the area value to the back of the list. And so this list areas will grow bigger by one element at each. I think we can get rid of that print area now. Get rid of at each step of the loop. If I move it, oh yeah. Okay, so let's again always test very regularly. As soon as you really, especially if you're not sure what you're doing, you should write one line of code and then test. So here we are testing again. Okay, running step in. Okay, so now, variable explorer, areas, empty list, size 0, double click on it, nothing in it. Okay, now we step into the loop, d equals 5, area equals 19, areas.append area. So now if we look at areas, our list is now got 1 in it. And if we look at it, we've got 19.6, the area of a circle with diameter 5 has been added to the list. If we go again, now area equals 78, areas.append, it gets added to the list. We come up here, we look at the list, it's now got 2 elements in, right? And so on and so forth. It's got, keep an eye on the size of the list, right? It's got 3 elements in, it's got 4 elements in. Okay, so now we've got a list of areas for each of our four areas, 5, 10, 15 and 20, for each of our four diameters, 5, 10, 15, 20 in our input list. And of course what we want to do is ultimately we want to return that list of areas. So just as with functions and if statements and everything else, if you want to end the loop, the end of the loop is marked with get rid of the indent. So that means any code we write here doesn't get executed on every iteration of the loop. It just gets executed once the loop has finished. Okay, and the thing we want to do when the loop is finished is return the list areas. Okay, save, run, stop debugging, run. So now we've got this variable here, my diameters, which is a list of 5, 10, 15, 20, and we've got my areas, which has been calculated from this function, which is another list, 19, 18, 176, 314. Okay, so the areas of circles with those diameters. And of course we could make our list bigger, 25, 30, 35, and run again, and my areas would correspondingly get bigger. Okay, so that's a for loop. A for loop is a great way of doing something. If you have a list already and you want to do something with each element in the list, a for loop is a great way of doing that. It just executes the same piece of code over and over. And you can see why now it's so useful to have circle area from diameter in a function, because we called it, lots of times. And at each step, in fact, let's just to make that explicit, I'm just going to show you that. I think this should be clear to you, but just in case. Each time we went through this loop and we called this function circle area from diameter, of course, although if we press step in here, we can see that what actually happens underneath the hood is that each time in the list we actually go into this function, calculate the area, return the area, go back into this loop, around the loop again, if I step in, back into this function, circle area from diameter, calculate the area, return it, back in. So the code actually goes, each step it goes in, up in, through here, around, up in, through here, and around each time. Okay? So it does keep executing this same line of code as if you had written them one after another 6 or 7 times, but we didn't have to do that. That would have been annoying and it would involve us doing lots of copying and pasting, and the code would look like a mess on the page, and this is much neater.